So Daniel, give me sum up when we need to start, okay? Hello, everyone. Welcome to Math Kangaroo Daily Challenge Workshop. My name is Lucia Liu. I'm a Math Kangaroo faculty and teach kids strategies and techniques in solving math problems. I started a connection with Math Kangaroo since my son Noah was in third grade. At that time, we barely found any math competition for lower primary students until he met with Math Kangaroo, who runs the competition from first grade to 12th grade. Noah has participated in Math Kangaroo competition for 9 years in a row until now. As a 12th grader, this March would be his last Math Kangaroo competition. But he won't stop his Math Kangaroo journey. He now volunteers as TA in Math Kangaroo courses and webinars. Through Math Kangaroo, he found math is fun, math is cool, and math is everywhere. Math Kangaroo opened his mind on problem solving and critical thinking and laid a solid math foundation for him. Math Kangaroo usually opens registration in fall for next March competition. The in-person centers close in early January, but we do have some online test centers that still accept registration for this March competition until end of February. So you can see the screen. There is a website, mathkangaroo.org. You can check for more information. Math Kangaroo not only hosts competition every year, but also offers group and private lessons, webinars, and a lot of online math learning resources. Please visit mathkangaroo.org to find those information. Now, let me introduce our co-hosts from Daily Challenge, Daniel and Michelle. Daniel loves solving math problems, be it competitions or modeling. He also loves teaching and is currently the head coach of a math conf team. Outside of mathematics, he enjoys playing the cello. Daniel, please say hi to the students.
Hello, everyone.
Michelle is a 10th grader who loves math. She has participated in many competitions and last year received an honorable mention in the UMD math competition from University of Maryland. Outside of math, she enjoys playing violin, volleyball, and petting her cat. Michelle, please say hi.
Hi, everyone.
Next, I'm going to hand over to Daniel and Michelle to start our exciting journey today. Thank you.
All right. Hello, everyone, and welcome to the 2021 Math Kangaroo grade 7 to 8 live solve. So before we get started, can I get like a little poll to see where everyone is from? And to just send a message so we can see it, just send a message in the Zoom chat to the chat relay, and it'll show up right here. New Jersey, IALA. Oh, Los Angeles, California, Washington, Michigan. Wow, we have so many people from all over the world. All over the US, not the world. But yeah, Iowa.
Texas? Mars. Ooh, that's fancy. I want to go to Mars. I feel like living in Mars would be very, very cool.
Well, that's only if you could actually live there without like wearing all the spacesuits and everything, because I feel like that's really restrictive.
I think, yeah, probably. And like space food doesn't sound very good.
Yeah. California, a lot of Californias actually. But I am not seeing any of the best state, which is Maryland. But that's fine. It's okay if you guys are from inferior states. But yeah. So, it was very fun to see where you guys are all from. People in Ohio. Ohio doesn't exist. It's a lie. It's a myth. But yeah. Let's see if we can just start the math for today, because that's what you guys are here for, right?
Mhm.
So let's go ahead and look at the first problem. So here the question is, we want to find, oh, it's probably very not showy uppy. Okay, wait, give me 1 second. Let me see if I can see what parts are shaded. It's not showing up in the diagram, which is unfortunate. Let's see. Alright, so this whole segment up here is shaded. It's a lot better on Michelle's screen, actually.
Yeah, I can go ahead and do this problem if you'd like. Cool. So this is problem 2, and it says the figure shows 3 concentric circles with 4 lines passing through their common center. And it asks, oh, can you still not see the shaded parts? I'll put them in a darker color and hopefully that'll help out. So the shaded parts are here, this area, this area, this area. Okay, cool. That's awesome. This area and this area. And we're looking for the percentage of this figure that is shaded. And just looking at this figure itself, I can't really figure out the percentage shaded. So typically it might be easier to just move parts around and see if we can turn it into a shape that we do know how to find the percentage of. So if we take this shaded part over here, we can actually move it here. And we can take this entire part here, move it here. And we can finally take this small part here and move it here. So by moving these shaded parts, we've now turned it into just 1/2 of the whole circle. And so, as a lot of people are saying, like Anton, it is now 50%, which is our answer. Yeah, answer E.
Yeah, and I think it's really cool how it doesn't show up on this diagram, but how from not knowing any lengths at all, and in fact not actually finding any lengths in the problem, we're actually able to generate how much of the circle is shaded, just because the fact that 2 lines, when they intersect, they'll create equal segments on either side.
Mm-hmm.
All right, awesome. So let's go ahead and look at our second problem. So our second problem is a little puzzle problem where we want to put together segments. So I guess in a puzzle problem, the first place to start is always the ends, right? Because the ends are flat lines, and we like flat lines. Flat lines are great. Just like how in any puzzle you want corner pieces. Here, since it's here since there aren't really corner pieces, because it's not a really square puzzle, it's just a line puzzle, we just want to look at the ends that are flat. And you can see that this has a 2, and the 2 end is flat, which means our puzzle has to start with 2. Likewise, our puzzle has to end with 2 here. Starts with 2, ends with 2. So what about the other pieces? Well, let's first start with the piece after this 2. This 2 has an open forward segment, which means the next piece after the 2 has to be an open segment like that, right? With something here, we don't know what yet, but it has to have an open segment in the front. That's all that matters. And the only one with the open segment on the front is that 2, which we already know goes at the end, so we don't even need to care about that. And that 1. Sorry, not that 1, that minus. Which means this segment has to be minus. And I see a lot of people putting in the chat, yeah, using this exact same method, you can find that after the negative has to be the 1, and after the 1 has to be the 0. So our final equation becomes 2 minus 102, and that gives you negative 100.
Yeah, exactly. And now moving on to our next problem, problem 8. We have a 3 by 3 by 3 cube is made from white, gray, and black 1 by 1 cubes, as shown in the first diagram. And The other two diagrams show the white part and the black part of the cube, and the question asks us to find the gray part. So for this question, let's just look at the cube layer by layer by layer. So there are 3 layers in this cube, and in the first layer, the gray section is just this one small cube and like the back left. So we know that in the gray diagram, it should just be one cube on the top. So that eliminates option D, since option D has 2 cubes in the top layer. Looking at the second layer, which unfortunately we can't see all of, but we do see that there are 2 gray cubes here. So that goes ahead and eliminates option A because there's no cube here. And yeah. And finally, looking at the last layer, again, we can't see the whole entire layer, but we do see that there's 1 gray cube here and 2 gray cubes in the back. So since C is missing that gray cube and like the back bottom middle, we can go ahead and eliminate that one. And now looking at like B and E, we know that like in this diagram here, this one spot, hold on one second. Oh, my bad. So with the difference between B and E are these cubes in the bottom. And if we look at our initial diagram here, that cube is white. I'm sorry, I've like drawn over it so you can't see it, but it is white. So therefore, it cannot be gray, and so it can't be B, and our answer is E.
Yeah, that was a really cool problem. Just like taking a shape and just breaking it into little parts and seeing what those little parts look like and how they just like fit into each other nicely. All right, awesome. Then let's go on to our next problem, which is, about chocolate. I like chocolate. So here we have a rectangular grid of chocolate, and we're breaking it into pieces. But of course, with chocolate, to break it in pieces, you just have to like snap a little chunk off, and the whole part just falls off. So that's why we only can snap chocolate along the lines. So we know that Neil breaks off a piece of chocolate, and he breaks off a piece that's 2 squares wide and then 6 squares long, right? Because he eats a total of 12 squares. So we know that the chocolate bar looks something like either this, where we have like a 2 and like a really long part, or a 6 and also not necessarily as long a part, but just 6, right? Well, let's keep these 2 cases in account and then read the second part, which is that Jack breaks off a strip of length 1, which means if he breaks off a strip from this bar of 2, only way he could do that is if he does this. But if he does that, then all that should remain from the bar is the bottom 1 part. And we know that since Jack had to eat 9 squares of chocolate, that bottom part would have to also be 9 squares of chocolate. And that's not an answer choice, which means this first case must not be right. So let's go on and look at our second case. Let's just go and move this over here. So our second case is where we have a very long, not as long, not necessarily very long, sorry, piece of chocolate with 6 sides over there. Well then, if Jack eats a block of size 1, well, maybe they're very small chocolate, so that's a very good point, though, Smart. So if we break a little chunk off of segment 1, and this is 9, then we can physically have a bar that has length 5 here, and still side length 9, which means the remaining portion is 45. And 45 is an answer choice. So it's probably going to be 45, which is answer choice D.
Yeah. And I totally could see myself eating 12 pieces of chocolate in like one sitting. Honestly, a little bit of a problem. Now, onto our next problem. We have that Costa is building a new fence in his garden. He uses 25 planks of wood, each of which is 30 centimeters long. He then arranges these planks so that each amount of two adjacent planks overlaps by the same amount. We know that the total length of Costa's new fence is 6.9 meters, and we're asked to find the length of this overlap within each pair of adjacent planks. So we're looking for about this distance here. And we don't know it, but what we can do and what we can find is the distance if the planks were arranged like this. So they were just next to each other without that overlap. So without the overlap, we have that each plank is 30 centimeters and that there are 25 planks. So without the overlap, there is 750 centimeters of wood. And now let's take a look at what the overlap does. So in every overlap, we're like taking away one small bit of that original bridge. So let's just call that length x because that's what we're trying to find. And we know that between every two adjacent pairs, there is that small amount of x that's being like destroyed or whatever. And so between 25 planks of wood, there's going to be 24 lengths of x that is here in this like bridge version, but not in this bridge version. And so we can set up an equation. We know that if the planks were established side by side, it would be 750 cm. But we know that if we subtract 24 of those small overlap regions, we would then get 6.9 meters, so 690 cm. And solving this, we get that 24x is equal to 60. And so x is equal to 60 over 24, which is equal to 10 over 4, which is just 2.5. And so our answer choice is B.
Yep. All right. Let's go on to our next problem then. So our next problem is, 1 second, sorry, is about questions and points on a quiz. So here we have a quiz where Eric has 20 problems, and for every correct problem he does, he can get 7 correct answers. For every one he gets wrong, he loses 4 points. Well, let's think about like the best case possible, right? So what if Eric gets all his problems right? That'd be great, right? It would be amazing. Everyone would be happy, especially Eric's parents, and Eric would get 140 points. But unfortunately, this isn't this dream world where Eric gets 140 points because he misses some problems and he doesn't answer some problems, right? But we do know he gets exactly 100 points, which means he has to somehow lose 40 points along the way, yeah? Well, how can Eric lose 40 points? There are 2 ways. One way is that he gets a question wrong. And if we're thinking about where he gets all the questions right, when he gets a question wrong, suddenly he loses 11 points, not just 4. Because you're going from like a point of he has 7 points to a point of he loses 4 points, right? So that's actually going to lose 11 points. And if he just doesn't answer a question, he'll lose 7 points. So basically our question is actually how many ways, or like how can he lose 40 points by losing 11 points and 7 points at a time? A, if you get all of them wrong. That's actually not possible, because if he has to lose 40 points, he can't lose it 11 points at a time, right? Because he can get like 107 points or 96 points, but he can actually never get 100 points if he gets all of them wrong. But one thing he can do is he can lose 33 points from wrong answers and 7 points from right answers. And if he loses 33 from wrong answers, that means he gets 3 questions wrong. And if he loses 7 points from unanswered, he gets 1 unanswered question, which means the answer is going to be B1.
Yeah, that's very, very sad for Eric that he loses 11 points and not actually 7 for every question he gets wrong. And moving on to our next problem, we have 3 villages that are connected by the paths shown. And from down end to uphill, the detour to Middleton is 1 kilometer longer than the direct wiggly path shown. And then from down end to Middletown, the detour via uphill is 5 kilometers longer than the direct path. And then from uphill to Middleton, the detour via down end is 7 kilometers longer than the direct wiggly path. And we're asked to find the shortest distance between the following paths. There's like a lot of things going on, so let's just set some variables. Let's let the length from uphill to downtown be A, from down end to Middleton to be B, and from uphill to Middleton be C. So we know that by going from, if we want to go from down end to uphill, if I were to take the path going to traveling by B and then traveling by C, it would be 1 kilometer longer than if I were to just directly use the path A. So we know that A plus 1 is equal to B plus C. And similarly, we can find that when we go from down into Middleton, going the path B is going to take 5 kilometers longer than just going from, it's going to be 5 kilometers shorter than just going from A to C. And finally, when we go from uphill to Middleton, we know that taking path C is going to be 7 kilometers shorter than using A and B. And because of the symmetry between A, B's, and C's, we can actually just add them all up and get that A plus B plus C plus 1 plus 5 plus 7, which is 13, is equal to 2A plus B plus C. And so we get that A plus B plus C is 13. And now we can find A plus A, and we can find B, and we can find C, but that seems like a lot of work. And in reality, we only have to find the shortest distance. So the shortest distance between the villages. So we only need to find the smaller number between A, B, and C. So let's see if we can find which path is actually shortest. If we rewrite our equations like A1 is equal to B plus C minus 1, B plus C minus A, and 5 is equal to A plus C minus B, and 7 is equal to A plus B minus C, we can kind of get that if we're looking for the shortest path, then when we have this big number, the number that gets subtracted should be as small as possible, because anything that's subtracted is going to take away from this number. And so C should theoretically be the shortest path. And then we can substitute A plus B as 13 minus C, and we would get 7 is equal to 13 minus C, and we would get that C is equal to 3 kilometers, which is our answer. And conveniently, C is next to 3. So yeah.
Wow, that was a really complicated problem, actually. It looks so simple with just like 3 things, but that was a lot of work. All right, let's go on to our next problem then. We're getting very close to the end, actually. So here we have 2 6-digit numbers, and one of them is 2 ABCDE, and the other is ABCDE2. And we know that multiplying the first one by 3 gives us the second one. Well, how can this help us? Let's look at the last digit first, actually. Let's not, actually. Let's look at the first digit. So our first digit in both is 2 and A respectively, right? 2 and A. So 2 times 3 is 6, which could tell us immediately that A is 6. But that's actually a trick, because A can't be 6. Reason being, it's 2A stuff here, right? And 2A stuff times 3 gives us A. So for example, if A was 4, we get 24 to 72, right? And then in this case, 4 is not 7, so it doesn't work. But you can see how A isn't necessarily 6, right? So if A is not 6, what is it? If A is 7, then we got 27 and 80 something. And that's also bad, right? And if A is 28, we get 80 something, which is good. And that tells us A is 8. So life is good and we are happy. Oh, and if like A is 9, then what happens is we get 6, 27, 87 something-ish, right? So it's probably 8. All right, so if this is 8, 28 times 3 is 84. So it's like 4 plus something, where that something is 0, 1, or 2, right? And then you have your something there again. So it's basically like what we had up here with like 2 and the A, except now we have like a 4 and a, not 4, sorry. Give me 1 second, sorry. Maybe it's better to start at the back, actually. Yeah, let's start at the back. So if we have a, if we have a 2 at the end, then we actually have to have a 4 there, right? Yeah, that's definitely a better way to solve it. Sorry, guys. But if we have a 4 there, that means we have a 4 here. And if we have a 4 here, what do we have to have there? So if we have 3 times something, question mark, 14, 42, well, that hints at that question mark being 1. Right? And it could be other things, but let's just ignore that for now and just assume it's 1. Because if like, okay, the reason it could be other things is because if it was like, let's say 34, it doesn't do this, but 3 times 34 would give us like 112. No, wait, what was I thinking? No, I had something smart, I swear. Give me 1 second, sorry guys. Okay, wait, no. I think it does have to be 14. I lied. All right. Minorly confused here, but that's fine. So if we have a 14 here and a 42 there, then we have some blanks here. And we know this is 2. We have A, B. And then we have A, B, C, right? And we already determined from above that like A is probably going to be 7, I think. No, 8. And we can do more with this. We know that B times 3 is going to be C. And then 8 times 280B times 3 is equal to 800BC. So then this is 84 plus 3B is equal to 800 plus 10B plus C. So 7B, no, sorry, 40 is equal to 7B plus C. And then from this, we can clearly see that B and C have to be 5, right? Because if B was 6, too much, B is 4, too little, because then C would have to be 12, and C has to be 1 digit. So yeah, and if B and C are both 5, everything should work out nicely. So then we should have 2, let me use a different color so we can see it. So we have 285, 14, no. Sorry guys. I did something wrong. Wait, Michelle.
Yeah.
Could you?
Yeah. So I think that this problem is very, very interesting because there's so many different ways to approach it, and each way has like a bunch of like drawbacks and like advantages. So I would just like to like show a new way that does require more arithmetic, but does use a bit less logic. So if we notice in the numbers that A, B, C, D, and E are all kept together. So it's like the first number is 2 A, B, C, D, E. And the second number is A, B, C, D, E, 2. So what if we just let A, B, C, D, E be a number? So what I mean with this is like if the A, B, C, D, E was, if A was 1, B was 2, C was 3, D is 4, and E is 5, then this new X number that I'm defining as A, B, C, D, E is just 1, 2, 3, 4, 5. And with this information, we can actually set up a system, an equation we can solve. And we can directly solve for A, B, C, D, E to find the sum of the digits. And for the 6-digit number, the number that is getting multiplied by 3, we know that this is 2 times 10 to the, hold on, let me count the digits. 1, 2, 3, 4, 5. 2 times 10 to the 5 plus that A, B, C, D, E. So in this case, I'm calling it X. And this, when multiplied by 3, is equal to this A, B, C, D, E times 10. So in this case, 10X plus 2. And just doing a little bit of algebra, we get that 6 times 10 to the 5th is equal to 3X plus 3X is equal to 10X plus 2. And that 6 times 10 to the 5th minus 2 is equal to 7X. And unfortunately, as I said before, every strategy has its advantages and drawbacks. And now the drawback of this strategy is very clear because I have to divide a very, very big number by 7, and it's not making me happy. But we can make this slightly easier on ourselves by factoring out the 2 ahead of time, because we know that since the 2 is not originally divisible by 7, and we're going to assume that X is going to be an integer, this number inside is going to be divisible by 7. So we can just kind of divide that by 7 and it'll work out. I don't actually see a good trick for solving this. Daniel, do you have an idea?
No.
Okay, so let's go ahead and bash this out. So we have 2, 9, 9, 9. Hope, make sure I write the right number of 9s here. 9, 9. Is that 1, 2, 3, 4, 5? Is that right? Hopefully. Divided by 7. Algebra, I love you sometimes, but this is not 5. Anyways, 4, 28, 1, 9, 2, 5, 9, 8, 3, 9, 5, and then 7. So this is just, yeah. So we have that 2 times this number, 4, 2, 8, 5, 7 is equal to X. And now, again, more algebra, lovely. I'm running out of space. To find X, we just have to multiply 4, 2, 8, 5, 7 by 2. 14, 1, so that 1 goes here. 11, 1, that 1 goes here. 7, 1, that 1 goes here. 5, 8. And then it asks for the sum of the digits. So remember that our number isn't actually this A, B, C, D, E, or this X. We're actually looking for the sum of this number or this number. So you have to remember to add a 2 on either end. And so we get 8 plus 5 is 13, 13 plus 7 is 20, 20 plus 1 is 21, 21 plus 4 is 25, and 25 plus 2 is 27, which is our answer. So yeah, this problem is, just really, really tricky. And I think there's so many different ways to approach it. I feel like this way is the quote unquote easiest, but very bashy. Whereas the way Daniel showed us was really what is like really more fast, but also really more difficult because there's just so many things you have to keep track of, you know? And yeah, so everyone, there's so many great messages in chat, so I'm gonna give all of them stars. Yeah, continue being so active. Yeah, thank you. Let's take a look at our next problem. Oh, it's about kangaroos. How surprising. Okay, we have 2021 colored kangaroos are arranged in a row, and they're numbered 1 through 2021. So kangaroo 1, kangaroo 2, kangaroo 3, blah, 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 blah. Anyways, each kangaroo is colored red, gray, or blue. And among the consecutive kangaroos, there's always kangaroos of all three colors. And so what this kind of means is that if I have a kangaroo of, say, color A, and then kangaroo of color B, and then kangaroo of color C, within every three kangaroos, all of them have to be different colors. And now we have this guy named Bruce, and he guesses the colors of 5 kangaroos. He says, hey, kangaroo 2 is gray, kangaroo 20 is blue, kangaroo 202 is red, and kangaroo 1002 is blue, and kangaroo 2021 is gray. And we're told that only one of his guesses is wrong. So which of his guesses is wrong? Before we actually try to figure out which his guesses are wrong, let's first see if we can figure out any information from this statement, that among any 3 consecutive kangaroos, there are always kangaroos of 3 colors. So for the first 3 kangaroos, we know that they all have to be 3 different colors. And let's just call the colors A, B, and C for now. So the first 3 kangaroos have to be colored A, B, and C. And now for this 4th kangaroo, we know that in this group of 3, kangaroos 2, 3, and 4, there also have to be all different colors. So this kangaroo group is missing an A, so we're just going to add an A over there. And if we continue this process, what we're doing is we're basically saying, okay, because in every 3 consecutive groups of kangaroos, there are 3 different colors. When I remove a kangaroo from a group, so almost think of it as when I went from ABC to BCA, I removed that kangaroo A. I now need to make it up. So I now need to add that colored A kangaroo to the end. And what we end up getting is this really cool pattern of ABC, ABC, ABC. And you guys can definitely work this out on your own. And if you're not too sure that this is actually what happened. And now with this information that we know that the colors must be alternating red, gray, blue, or blue, gray, red, in some alternating 3-color pattern. Daniel, how would we actually figure out which of his guesses are wrong?
Well, they give us 5 kangaroos of different colors. What if we take all of those numbers mod 3? Because after all, every 3 kangaroos, you go back to the original colors. For example, if you started out with red, then blue, then gray, you'd go to red, then gray, then red, then blue, then gray, and then all the way around, right? So if you think about kangaroo 2, 2 is equivalent to 2 mod 3. And then 20 is equivalent to 2 mod 3. So we know that kangaroo 2 is gray, maybe. Kangaroo 2 is blue, maybe. Kangaroo 1002 is 0, so it's going to be 3. And 1002, his prediction was blue. 202. 202 is going to be 1 because 201 is 0. So 1 is possibly red. And we also know 2021 is going to be 2. And it's pretty clear, great, that the kangaroo number 2 is the part where the contention comes in, right? So kangaroo 1 has to be red, kangaroo 3 has to be blue, and if we have red and blue, third one has to be gray, which means the guess that 2 is blue is wrong, and our guess that 2 is blue is actually kangaroo 20, which means kangaroo 20 is the one they got wrong.
Yeah. I've got to say, that's a pretty good guess rate. I mean, theoretically, if you were to guess randomly, you have a 1/3 chance because there's 3 colors of guessing the right kangaroo. But out of 5 kangaroo, Bruce guesses 4 correctly. Theoretically, you would expect him to get 1 or 2 correct, but Bruce must be some like weird psychic wizard or something. Cause like, yeah, nice.
Yeah, the probability that he guesses all 5 or 4 out of 5 is like, what is that? That's 5 over 243. Like those are insane numbers.
I
No,
know.
it's not 5 over 23. It's like 10 over 243. But still, like that's crazy. Like 1 out of 24. Yeah.
Good job, Bruce.
All right. Let's look at our last problem, I think, which is
Ooh.
about TV stations and matches. So here we have a series of games played between 6 teams, or they just play everybody else. And we want to find out when Team D plays against Team F. And it seems like we don't really have much information, do we? Because we're only given one game that happens during each of those 5 matches. But actually, that information is very useful. Let's take, for example, Team A. Team A plays Team B, Team C, Team D, Team E, and Team F. And we know that the first game is Team B, third game is Team E, fifth game is Team C, which means we're just missing the matches against D and B. Wait, no, sorry. D and F. Sorry, I can do my letters. D and F. But our second match and our fourth match are the only one that are empty, right? So we know that their matches against F and D have to be sometime in those two, AF and AD. But in the second game, D's already playing a game, so they can't play a new game. So AD has to be in the 4 slot. And also, AF has to be in this slot. Why is that good? Well, that actually tells us a lot of information. Because there are only 6 teams after all. If 4 teams play in a single day, those last 2 teams also have to play. So A plays D and E plays F, then B and C must play each other this game. And if A and C and D and F play, then B and E have to play this game. And speaking of E has played a lot of games. E plays A, B, F. It's just missing D and C. Well, C's playing here. So C has to play here. And therefore D has to play there. And from this, it's pretty clear when D plays against F, right? Because game 1 is where we only have A, B, C, and E, which means that has to be the one where D plays against F, which means our answer is actually going to be the first match.
Yeah, I think this was probably the hardest problem on this, for me at least, on this whole entire set, because I think intuitively you kind of start with trying to figure out which round D and F play, because we're looking for D and F. But because of this chart doesn't give us enough information about D and F, we actually have to start with A, which is actually just really, really weird. Yeah. And that is it for our live solve today. I hope everyone had a great time. You can do more at like this link over here, or you can scan these QR codes and get more information. Our next level 7 to 8 live solve will be on March 24th at 8 p.m. So I think same time. And I hope to see you guys there. Yeah, bye.
Yep, and if anyone has any questions about any of the problems we went over, feel free to stick around. We'll be here for a bit longer, so yep, if you have any questions, feel free to just type them in the chat.
Yeah.
Otherwise, see you guys.
So Martha, if you would like, we would love to go over some more problems with you. So yeah. Or with anyone, in fact. Bye. Daniel, did you ever do math